Unit 9, Objective 5 introduces you to the 3 laws of logs. I'm not going to do a whole lesson on what they are, but I will do a summary of how I wrap it all up when I'm teaching this to my class. Number 1, single log multiplication is double log addition. So I'm just using log base 2 for my examples. But if you have log base 2 of AB, that can be broken up to log base 2 of A plus log base 2 of B. Single log multiplication is double log addition. Number 2, law number 2, single log division is double log subtraction. So log base 2 of A divided by B is log base 2 of A minus log base 2 of B. And then number 3, I really don't have a short little summary for it, but this is the way I wrap it up. The leading coefficient of a log term began its life as an exponent. So if you have a log term that has a leading coefficient in front of it, B times log base 2 of A, then what you will probably wind up having to do is put that leading coefficient back in its exponential position where it began. And the rest of the objective is just a few examples of working with this. So let's take a look at a few of the problems. Problem number 6. What if you had the natural log of e cubed over 5? Now, there's a few laws we're going to use. First of all, I see a big fraction bar, which means division. So I'm going to put the natural log of e cubed minus the natural log of 5. That takes care of the rule that division turns into subtraction. Single log division turns into double log subtraction. But now I have that third law I have to deal with, and that is the exponent. E is actually being cubed. So what I need to do is bring that 3 down in front. I have to treat it as a leading coefficient. So this is 3 times the natural log of E minus the natural log of 5. Now I can do some more simplifying because I know what the natural log of E is. Remember, the natural log is just a log that has E as its base. And anytime you're logging something with the base and the number you're logging match each other, you know that answer is 1. So the natural log of E is 1. So this is 3 times 1 minus the natural log of 5. 3 times 1 is 3. So it's 3 minus the natural log of 5. And there's your most simplified answer you can get for this problem. Okay, moving on to number 12. This log is written in base 10 because, I don't see a little number down there, so I know that that's a 10. And I've got actually 3 things being multiplied with each other. 1,000 is being multiplied with x cubed, which is also being multiplied with the cube root of y. So I'm going to take the rule that says single log multiplication turns into, in this case, triple log addition. So if I expand this, this would be the log of 1,000 plus the log of x cubed plus the log. Now I'm going to take care of another step right here. The cube root of y is going to be rewritten as y to the 1/3 power. So I'm going to change it out of radical form and into exponential form. Now I'm going to simplify and see, what all can happen with this. Well, the log of 1,000, remember there's an invisible 10 right there. So what power turns the number 10 into 1,000? Again, that's a 3. So the log of 1,000 is 3 plus, now I'm going to use law of logs number 3 to take that exponent and bring it down and make it a leading coefficient. And as long as I'm doing it there, I might as well do it here too. So finishing off the rest of the expression, this would be 3 times log x plus 1/3 times the log of y. And that would be our answer. Now, moving on to problem number 18. 2 log x plus log 11. If I'm going to now simplify this, I see it as a double log with addition, so it's going to ultimately be a single log with multiplication. But before I do that, I need to do this. I need to move that 2 back to its original place. So this would be the log of x squared plus the log of 11. Now I've got double log addition, which can be re-expressed back as a single log as long as I multiply these two terms right here. So x squared times 11 is simply 11x squared. Okay, finishing off a couple more examples from worksheet 5. Let's take a look at problem 25. I'm looking at 2 logs that are being added together, so I know at some point to turn them into a single log, I'm going to have to do some multiplication, but I'm not ready to do that yet because of the leading coefficients. Let's take care of the leading coefficients. We know that that leading coefficient of 2 right there needs to get moved back to there. And we also know this 2 needs to get moved back to there. Now, let's take a look at what we've got at this point. I've got the log base 6 of 2 squared, which is 4, plus the log base 6 of 3 squared, which is 9. Now, I'm going to take these 2 and turn them from double log addition to single log multiplication. So what I'm going to wind up multiplying the 4 and the 9. So if I condensed those 2 to a single log, it would be log base 6 of 4 times 9, which is 36. And the log base 6 of 36 simplifies down to the number 2, because 6 squared is 36. Okay, problem number 29. They give you a hint in the instructions for those last 3 problems. They say, turn any constant into a log. So that's what we're going to do. The other 2 terms are written in log base 2. So I'm going to turn 3 into log base 2 also. So the number 3 is log base 2 of the number 8, because 2 cubed is 8. And then I'm just going to rewrite the rest of the problem. Minus 1/2 log base 2 of x plus log base 2 of y. Now, before I start condensing to a single log, I need to take care of my leading coefficient. Okay. My leading coefficient goes up there. So I'm going to rewrite almost everything in the way it is, but I am going to change the log base 2 of x to the 1/2 power. I'm going to take it from its exponential form to its radical form. X to the 1/2 power is the same thing as log base 2 of square root x, and then plus log base 2 of y. Now, I'm going to condense these two, because I can't work with all three at once. So I'm going to condense these two. Double log subtraction is single log division. So this would be the log base 2 of 8 over square root x plus log base 2 of y. Now I have one more step. Now I have to condense these two. Not condense, condense these two. And since this is double log addition, then this would be single log multiplication. So the y is going to end up with the 8 on top. So the answer is going to be log base 2 of 8y over square root x. Probably one of the tougher problems on the worksheet right there, if not the toughest. But there's your answer.